Hello everyone, welcome back to my YouTube channel. In this video, I want to explain a question from Past Paper EJU Mathematics 2020, Course 2, question number 1 from section 2. So this is basically the third question from this whole past paper. By the way, I do not know this past paper comes from which session. So if one of you know this past paper comes from which session, you can chat or leave your comment in the comment box below. Before I start, if you like this video, don't forget to give me your like buttons, share this video to your friends, and don't forget to subscribe my YouTube channel. For the other problem on this paper, you can check link on the description box below, and you can also check my EJU playlist if you want to watch the solution from the other past paper for your EJU preparation. Okay, let's start to solve this question. The question a little bit blurry, yeah? So if you guys want to see the question more clearly, you can change your resolution into HD. We have AN, and then the sum of the sequence of AN, denoted by SN, is given by this formula. So Sn is the sum of the sequence of An. I will write it down the formula of Sn so you can see it more clearly. Basically, Sn is equals to n squared minus 17n over 4. And then we have another sequence Bn. Bn is defined by An times An plus 5. So Bn is equals to An times An plus 5. For A until C, we need to choose the correct answer from the choices below. The objective of this question is we want to find the sum Tn of the terms of sequence Bn, from the first term to the nth term. So we want to find the sum of the sequence Bn, which is denoted by Tn. First of all, they ask us to find An, and then they ask to find Bn, and lastly, we can find Tn. So I need to find An first. If you see from the beginning of this question, they give us the sum of the sequence of An, which is Sn. Since Sn is a quadratic function, you need to remember, yeah, if the sum of the first n terms can be expressed as a quadratic equation or quadratic functions, that means An is an arithmetic progression. So, since I already know that An is an arithmetic progression, we can find An by finding its first term and the common difference. So this is what should I do now. I need to find A, which is the first term, and then I need to find D, which is the common difference. To find the first term, I can substitute n by using 1, and I will obtain S1 is equals to 1 squared minus 17 times 1, basically 1 minus 17 over 4. I got negative 4. This is our first term. Because S1 is the sum from the first term to the nth term. If I substitute n by using 1, then S1 is the sum of the first to the first term, which is the first term itself. So negative 4 is equals to my first term, which is A1. And then by changing n with 2, I will obtain S2 equals to 4, 2 squared minus 17 times 2, 4 minus 34 divided by 4, and then you will obtain negative 10. S2 basically the sum of the first second terms. So negative 10 here, basically the sum of the first term and the second term. Since I already know that the first term is equals to negative 4. Wait a second, I think I made a mistake, yeah? This is not negative 10, but negative 30 over 4. Sorry for these careless mistakes. Basically negative 30 over 4. Negative 30 over 4 is, I write it down in decimals, then I will obtain negative 7.5. Negative 7.5 is equals to A1 plus A2. By substituting A1 with negative 4, I can obtain A2. A2 is negative 3.5. Basically, this is your second term of the arithmetic progression. After I got the first term and the second term of arithmetic progression, I can directly find the common difference. If you are not sure whether this is an arithmetic or not, you can find by using the same method as 3. And then after this, you can find A3. Then you have the first 3 terms of AN. This is the first one, this is the second one, and this is the third one. By finding the common difference of these first 3 terms of arithmetic, you can sure that AN is an arithmetic progression because the common difference is constant or consistent. Okay, so I will directly find common difference here. Common difference, basically the second term minus the first one. So negative 3.5 minus negative 4, I will obtain 0.5 for the common difference. After I got the common difference and I know the first term of this arithmetic progression, I can find the formula of AN. In arithmetic progression, AN is equals to A1 or the first term plus N minus 1 times D. D basically the common difference. A1 is negative 4 plus N minus 1 times D. D is half. If I expand it, I will obtain negative 4 plus half N minus half. As you can see here, negative 4 minus half, you will obtain negative 9 over 2. I will write it down here, yeah? Wait a second. Negative 9 over 2 plus N over 2. If you express it in single fraction, you will obtain N minus 9 over 2. Basically, this is your AN. So, the correct answer for letter A is number 1, N minus 9 over 2. Once I got AN, it is easy for me to find BN because BN is AN times AN plus 5. So after I got AN, I can find BN, which is equals to AN. I already know AN, N minus 9 over 2, and then times AN plus 5. Since AN is N minus 9 over 2, so if I want to find AN plus 5, I can change this N into N plus 5. Then I will obtain N plus 5 minus 9 over 2. By simplifying this expression, I will obtain N minus 9 times N minus 4 over 2. We can expand the numerator and it will become N squared minus 13N plus 36 over, wait a minute, once again, I made a silly mistake here. It should be 4, not 2, yeah? 2 times 2 is equals to 4. So my final answer is n squared minus 13n plus 36 over 4. This is our Bn. So the correct answer for letter B is n squared minus 13n plus 36 over 4, which is number 4. After I got Bn, I think we can find Tn, because Tn is the sum of the terms of sequence Bn from the first until the nth term. I will write down below here. Basically, Tn is equals to the sum of the first n terms of Bn. Since I use k as my variable, then I can change n here into k. So Bn is equals to k squared minus 13k plus 36 over 4. K squared minus 13k plus 36 over 4. This is my Tn. If you want to evaluate this summation, first of all, we can separate the fraction first. I think this is the easiest way to evaluate this summation. So I will separate the fraction first, and I will obtain k squared over 4. I can write it down as 1 over 4 k squared, and then minus 13k over 4 minus 13 over 4k plus 9. 36 divided by 4 is equals to 9. And then by using the summation properties, we can give this summation into each term. So I will obtain sum of 1 over 4k squared minus sum of 13 over 4k plus sum of 9 from k equals to 1 until n for both summation. And then the last part is you need to remember what is the formula of sum k equals to 1 until n for k squared, and then sum of k equals to 1 until n of k, and then sum from k equals to 1 until n of 9. You need to remember the formula. I will write down the formula here. Basically, if you want to find sum of k equals to 1 until n of k squared, it will becomes 1 over 1 over 6n, n plus 1, 2n plus 1. And then if you want to find the sum from k equals to 1 until n of k, the formula is 1 over 2n, n plus 1. If you want to find the sum from k equals to 1 until n of a constant, so a here is a constant, then the result of the summation is a times n, an. I think to solve this question, you need to remember these three formula. So when I want to find the sum of k squared, I can substitute it by using this one. Then I will obtain 1 over 4 times this whole things. 1 over 4 times 1 over 6n, n plus 1, 2n plus 1, minus, for the second term, summation of k, I can use this formula. So 13 over 4 times this. 13 over 4 times half n, n plus 1. And then for the last part, I will obtain sum of 9, yeah? Sum of 9 is 9n. So 9n here. By simplifying this expression, I think we can find the answer for letter C. So now we need to simplify this expression. First of all, I will times 1 over 4 by 1 over 6 here. I will obtain n over 24, n plus 1, 2n plus 1, minus 13n over 8, times n plus 1, and then for the last term I have 9n. I will make the denominator into 24 so we can factorize it. So for the first term, the denominator is already 24, so I do not need to do anything. For the second term, I can times 3 over 3 to make the denominator becomes 24. And then for numerator, 13 times 3, we have 39. Over 24 times n plus 1. And then for my last term, I can times 24 over 24 to make the denominator becomes 24. 9 times 24 is 216 over 24. Don't forget to put n here. Since the denominator is already 24 and then in the numerator we have n on all the terms, I can factorize n over 24. For the first term, I have this one. I will directly expand it and it will become 2n squared plus 3n plus 1. You can expand it by yourself, yeah? If you expand it, you will obtain this expression. And then for the second term, I have negative 39 times n plus 1. Negative 39 and minus 39. I directly expand the 39 into the brackets. And then for the last term, since n over 24 is already factorized, then for last term I have 216. If I keep simplifying the expression, I will write it down here maybe. Tn is equals to n over 24 times 2n squared and then 3 minus 39, you will obtain negative 36n. And then for your last term, 1 minus 39, which is negative 38. Negative 38 plus 216, you will obtain 178. We can factorize 2 because all the terms here has common vector 2. So if I factorize 2, it will becomes 2n over 24 n squared minus 18n plus 178 divided by 2 is 89. Of course, you can cancel out 2 and 24 here, becomes 12. Then your final answer for Tn is equals to n over 12 or n open bracket n squared minus 18n plus 89 over 12. So your final answer for letter C is number 9. N times n squared minus 18n plus 89 over 12. Yep, it's number 9 for letter C. Let's continue to the next part of this question. The next part is, let us find the minimum value of Tn. So the objective now is we want to find the minimum value of Tn. Remember, I already got Tn. When n less than or equals to blah blah blah, or n greater than or equals to blah blah blah, we see that Bn greater than 0. So now my focus is, what is the condition for Bn greater than 0? My Bn is, wait a second, this one. So n square minus 13n plus 36 greater than 0. I will write it down here. Bn greater than 0. That means n square minus 13n plus 36 greater than 0. N square minus 13n plus 36 over 4 greater than 0. By solving this inequality, I think I can obtain D, E, and F. First of all, I can cross multiply 4 to the other side. 0 times 4, of course, it is 0. So my inequalities becomes n square minus 13n plus 36 greater than 0. I can factorize this quadratic equation and it will becomes n minus 4 n minus 9 greater than 0. That means my critical value is n equals to 4 and n equals to 9. I can put this critical value on a line number or number line. The first one is 4. Don't forget 4 is open interval because 4 is not inclusive. And also 9. 9 is also not inclusive. And then by checking the sign, if I substitute 5 to the equation, I will obtain the sign in between 4 and 9 is negative. That means the sign in the first and last region is positive. Since I want to find the region where the inequality greater than 0, that means I will take the positive sign. Therefore, n is less than 4 and n greater than 9. If you see these inequalities and you compare it with the inequalities or the set of values of n in the question, my inequality is not inclusive, but this inequality is inclusive. That means n must be less than or equals to 3. Remember, n is the number of terms. So it cannot be a decimal, it must be a whole number. So n less than 4 here can be thought as n less than or equals to 3, and also n greater than 9 here can be thought as n greater than or equals to 10. So this is my answer for letter D, E, and F. D is equals to 3, and then E and F is 1 and 0, which is 10. On the other hand, when n is between G and H, we see that B of n less than 0. When I want to solve B of n less than 0, the process is similar like the previous one, unless the inequality here is less than. So instead of greater than, the inequality here is less than. That means I can use the same number line, but instead of taking the positive region, in this case I will take the negative one. So I do not take the positive region, I will take the negative region as my final answer. This one. So 4 less than n less than 9. By using the same way of thinking, 4 less than n less than 9 in this range, 4 and 9 are not inclusive, but in the question they want us to write down a closed interval. So instead of 4 and 9, my final answer for G and H is 5 less than or equals to n less than or equals to 8. So G and H here is 5 and 8. The last part is hence Tn is minimized at n equals to blah blah blah, and its minimum value is blah blah blah. You need to remember Tn is the sum of Bn. Tn is the sum of Bn. We already know that B1, B2, and B3 is positive. So when n less than or equals to 3, it's a positive number. So if I write down like this, yeah, B1, B2, B3. For B1, B2, B3, it is a positive number. Don't forget Tn is the sum of Bn. You need to remember this one. B1, B2, B3 is a positive number. 4 is 0 because n equals to 4 is the critical value. So B4 is 0. And then B5 until B8 is negative number. B5, B6, B7, B8. This is all negative numbers. B9 is equals to 0 because 9 is the critical value. B9 is equals to 0. And then B10 and so on is a positive number. B10 and so on is all a positive number. By looking at this illustration, you can deduce that Tn, which is the sum of Bn, is minimized at n equals to 1 because this is the first term, 1. And then, as you can see here, something plus something, the number will increase, yeah? Plus another number, so it will increase again. Plus 0, do not change. And then you add it with a negative number. So, B1 plus B2 plus B3 plus B4, in this process, the Tn is increased. And then after that, Tn start to decrease until B8. So my next n where Tn is minimized is 8. Because the sum is start to decrease from B5, 6, 7, and 8. Because B5, 6, 7, and 8 is a negative number. So this J is 8. And then the last one is 9. Because after you have B8 and then you add it with 0. So the value of Tn do not change because you add it with 0. So the last value of n here is 9. Hopefully you can understand my point, yeah? And then the minimum value is blah blah blah. We want to find the minimum value. I think n equals to 1, n equals to 8, and n equals to 9 will give the same value because there is only one value here. So to make my calculation more simple, I will take n equals to 1. You can try by yourself. When n equals to 8 or n equals to 9, you can find the value of Tn. I think the answer is the same. Remember that our Tn is equals to this one. This is Tn. So by substituting n equals to 1, I will obtain the minimum value of Tn. 1 open bracket 1 minus 18 plus 89 over 12. Negative 17, 18 minus 17, you will obtain 72. 72 divided by 12 then the minimum value is 6. So the answer for letter L is 6. You can try by yourself, substitute n equals to 8 or 9, and you can see whether the answer is the same or not. But my guessing is the answer will be the same. Okay, that's it for this video. Hopefully you can understand my explanation, and hopefully I can see you guys on my next video. Thank you and bye-bye.